Question 21. We have a centre of a circle, has coordinates -5, 2, and the point A has coordinates 3, 7, and that lies on the circle. So I think of any circle, the centre is -5, 2, and a point on the circle is 3, 7. We want to find an equation of the tangent to the circle at A. So this is A. We want an equation of the tangent. Now, one thing we know about tangents to circles is they are perpendicular to the radius. So if I can find the gradient of the radius, I can find the gradient of the tangent. I know a point that it goes through, so I should be able to figure this out. The gradient of the tangent is the change in y divided by the change in x. So if I do the change in y, that's 7 take away 2, divided by the change in x, that's 3 take away -5. That gets me 5 over 8. That's the gradient of the radius. The gradient of the tangent is the perpendicular gradient. And a gradient times by its perpendicular gradient should equal -1. It always equals -1. So my gradient here, if I times both sides by 8, divide both sides by 5, I get my gradient being -8/5. In other words, the negative reciprocal of the other gradient. And I go through the point 37, the equation of my line. So the equation of my line, my tangent is going to be y equals -8/5 x plus c. Make sure that's clearly an 8. And it goes through the point 37, so when y is 7, x is 3, so 7 equals -8/5 of 3 plus c. So I can multiply both sides by 5 if I wish to get 35 equals -8 times 3, which is 24. And then don't forget to multiply the c by 5 as well, plus 5c. I can add 24 to both sides to get 5, 9, 59 equals 5c. Therefore c equals 59 divided by 5. 59 divided by 5. But we want the equation in the form ax plus by equals plus c equals 0. So we have 59 over 5. So we have y equals -8/5 x plus 59 over 5. I can multiply everything by 5 in this case to get 5y equals -8x plus 59. I can add 8x to both sides to get 8x plus 5y equals 59. I can then subtract 59 from both sides to get 8x plus 5y. Subtract 59 equals 0. And that's our final answer. We get 1 mark for correctly identifying the gradient of the radius, 1 mark for then therefore using the gradient of the perpendicular gradient to that. You get 1 mark for substituting your coordinates in and finding a value for your constant, and then 1 mark for your final solution in the form that it asked for.